Hello everyone. In this video, I will be discussing design patterns and software engineering, what they are, their categories, and how they solve software problems efficiently. We will also look at examples, diagrams, and practical scenarios to make the concept clear and applicable. So now let's start by understanding the foundation, what a design pattern really is. A design pattern is a reusable blueprint for solving recurring software problems. Think of it like an architect's blueprint. It guides construction, but it is not the building itself. Developers reuse patterns because they save time, they reduce errors, and make software more maintainable. In this given diagram, it shows how a design pattern bridges a recurring problem and a structured solution. So, maghatag ko real-world analogy. Just like a cafe, it uses a standard menu to organize orders. So, ang software patterns, muna siya ang mag-organize og solutions to recurring problems. So, example, ang problem, coffee, naay chaos sa orders sa coffee. So, ang pattern natong i-apply na is the standardized menu system. So, ang solution ang mahimong solution is maging organized sa mga orders. So, it's that easy. So, now let's see the main types of design patterns. There are three main types of design patterns. First one is the creational. The creational controls objects creation. Example na ang singleton. Ang structural, it organizes objects. Then ang behavioral, it manages communication. Understanding these categories helps us select the right pattern for the problem at hand. Para mas maklaro, the creational pattern simplify objects creation and controls instantiation. An example for that is creating a single database connection or managing users' sessions. Next is ang structural pattern. Muna siya nagahelp og organize sa classes or objects to form a larger system. For example, making a legacy code compatible with new system using adapter. The behavioral pattern. It defines how objects interact, communicate, and share responsibilities. An example for that is an app notifying multiple users of a status change using Observer. Okay. Now that we know the types, let us look at a concrete example of the creational pattern, specifically called the singleton. So sa IT industry or sa coding, sa system, naman yun ay problem na may tabo yun. For example, kay creating multiple instances of the same class can waste memory or cause data inconsistency. So yun by using singleton, it ensures only one instance exists and it provides a global access point. So think of it like a company where naa siya'y isa ra ka HR manager na responsible for the employee records. Tanan naa didto kay naga-refer to that one manager lang. No duplicates. Another example for that is kanagong CEO sa company. Isa ra di ba ang CEO sa company, dili siya naga-duplicate. And another example for that, mura na siya backbone sa isa ka system. If matang apektuhan na siya, damay tanan. So yung na siya. Now let's explore its advantages and disadvantages. Ang advantage it saves resources, it ensures consistency, and centralized control. However, nana siya disadvantages. It creates a global state, which can increase coupling and make testing difficult. For example, in unit test, if one test modifies a singleton state, other tests may fail unexpectedly. So, naga-rely yun ang system, So, mura siya heart if wala na, dili na mag-function, or brain. Next, we'll look at a structural pattern, starting with the adapter pattern. Sometimes, we need old and new systems to communicate, but their interfaces don't match. Ang adapter mo ning mag-solve na problem. Kung naa siya na ang kuan, before example na lang, as you can see in the diagram, naa kay cable, which is mo na siya imong new system. Tapos ang legacy class mo na siya ang outlet. If you try nimo na siya og saksak, it will not work. So ang naa ang adapter to fix that problem. So naa mo ang cable, which is ang new system nimo, and naa si adapter. I-connect nimo ang imong new system or ang cable sa adapter. Tapos kana si adapter siya na ang mo saksak sa legacy or sa outlet, making them work together. So now let's compare adapter to decorator briefly. Ang adapter muna siya, it is more on compatibility, while ang decorator, it is like adding new behavior without changing the original class. For example, for that is decorating a coffee cup with extra toppings versus making a cup compatible with different coffee machine. So ang decorating a cup with extra toppings, muna siya ang decorator. Kaya wala may nausab, nag-add lang ka without changing the original class. While ang making the cup compatible with different coffee machine, so muna siya ang adapter, which is more on compatibility. Now, mag-move on na ta, dirian na ta sa behavioral pattern, which I will cling on observer pattern. When multiple objects depend on the one component and must stay updated automatically, we use observer. Sa diagram, mura ni siya og social media notification. If imuhang friend nag-post and ikaw naka-follow kasi og napod siya uban followers, tanan followers including you ma-notify mo without manually checking it. Nanay mo gawas kay naka-follow magud mo ana siya. So naka-observe mo. Another behavioral pattern is strategy pattern, which improves flexibility in choosing behaviors. Ang strategy pattern, it separates algorithm from the main logic, letting the program switch to strategies at runtime. An example ana kay a game character, pwede siya mag-switch og attack strategies without rewriting the main combat logic. So ingon ana. So diri ta sa applied analysis. In an online delivery system, observer can handle real-time tracking notification. Factory can create delivery objects like car, bike, or truck depending on the package and location. This is how patterns solve real problems. Now that we've learned different design patterns, let us see how they can be applied in a real-world system. Assume that you are designing an online delivery system and mag-identify ka og 2 design patterns that you would apply and explain nimo why and ngano sila appropriate. So, for me, in delivery system, we have orders and users tracking those orders. Users needs to receive updates automatically whenever the order status change. For example, anang pending or shipped, delivered. So, ngana na siya. Instead of tightly coupling each users to the order system, we can use the observer pattern. So, diagram. Here, the order is the subject and the user tracking it are observers. When the order status updates, all users will be notified automatically. Next, we will look how we create different delivery types for the system. So, diri na ang factory pattern i-apply. In an online delivery system, packages can be delivered using different methods like bike, car, or truck depending on the size, distance, or type sa item. Instead of creating each type manually in multiple places, we can use the factory pattern to handle creation. So I will show you the diagram. The factory decides which delivery object to create based on the order attributes. This makes the system more scalable. Adding new delivery type requires changing only the factory, not the rest of the code. So if you combine na nato ang observer o factory ng diagram dra, by combining them for real-time notification and factory for delivery object creation, we achieve a system that is both responsive and scalable. Each pattern solves a specific problem. So sa observer, it handles communication between objects without tightly coupling. Then sa factory, it handles object creation efficiently and cleanly. So in this scenario, the observer ensures users always know the status of their order in real time, and sa factory, it ensures we can easily create new delivery types without touching the core logic. This is how design patterns make a system more organized, maintainable, and easier to extend. Now finally, let us evaluate the idea that using many patterns always makes a software better. To me, personally, I disagree with that statement. Because while pattern provides structured solutions, overusing them can lead to over-engineering, where the system becomes unnecessarily complex and harder to understand. So, patterns should be applied only when they solve real problems like our delivery system. For example, kuan manggod, like dili ka pwede mag spam na lang ka og design pattern para mo improve imong software. Doesn't work like that. If na specific na problem, mangita kag specific na pattern to solve that issue. It's just like that. So yeah. Now that concludes my discussion on design patterns in software engineering. We have explored what design patterns are, ilang main categories, which are three, and how specific patterns such as singleton, adapter, observer, and factory solves real-world problems efficiently. Na-analyze po nato ang ilang advantages, disadvantages, and how to apply them in a practical system like an online delivery app. I hope this presentation helped you clarify how design patterns make software more organized, maintainable, and scalable. Thank you for watching. That is all.